Let's look at the titration of a base that can accept 2 acidic protons. We could also do the same similar curve for an acid that releases 2 acidic protons. Okay, and so what we'll do is we'll look at the titration of 25 milliliters of a sodium carbonate solution, but we're only interested in the carbonate ions, and we're going to titrate it with HCl. Now this is a diprotic base, meaning it'll accept 2 acidic protons. Okay, but it's going to do it in 2 separate reactions, where the first reaction will accept the first proton, and the Kb value for my carbonate ion is that. And then when we look at the second proton being accepted to become carbonic acid, the Kb value for my hydrogen carbonate is 2.7 times 10 to the negative 8. And so we'll need these values as we go along. So for our initial pH, we'll look at pH at equivalency, pH at 1/2 equivalency, and our final pH. Remember, we're using these for sketching. Now, because this is diprotic, meaning that it can accept 2 protons, we're going to have 2 equivalency points. We're going to have the point where we take all of my carbonate ion and convert it to hydrogen carbonate. And then we're going to have the equivalency point where all of my hydrogen carbonate becomes carbonic acid. Okay, so I'm going to have 2 equivalency points and therefore 2 half equivalency points. So for my initial pH, it's only going to be due to the hydrolysis reaction that the ion causes. Obviously, we would do our ice table, and we could use our method approximation probably, and we get our initial pH of 11.8. Okay, our final pH is going to approach the pH of our titrant, or the acid that we're adding to it, okay, which would be a pH of approximately 0.4. So right away we have our initial and our final. Okay, so at our first equivalency point, we only have hydrogen carbonate ions and chloride ions present in solution. We know that our chloride ions won't do anything, but my hydrogen carbonate is amphoteric. It can both donate and accept a proton. And so the Ka value for it to donate and act as an acid is 4.7 times 10 to the negative 11. The Kb for it to accept a proton is 2.27 times 10 to the negative 8. So because my Kb is greater than my Ka, it's going to accept a proton. And so this helps us when we set up our reaction. This is what would be occurring at my first equivalency. Is my carbonate ion, hydrogen carbonate ion would cause a hydrolysis reaction that produces hydroxide. If the Ka value had been greater than the Kb, the carbonate ion would still cause a hydrolysis reaction, but I'd be producing hydronium ion instead. Okay, so now I do an ice table for this reaction, and I get a pH of 7.98. Okay, it makes sense because I'm producing hydroxide ion. But because I'm just over 7, it tells us that this reaction does not occur very much. So I can put my pH for my first equivalency. Now for our second equivalency, I'm only going to have chloride and hydrogen. We know that my carbonic acid can cause a hydrolysis reaction that produces hydronium ion. So I can set up my ice table and solve, and I get a pH of 3.7. Okay, so now I have my pH at my second equivalency point. So now I need my pHs at half equivalency points. Okay, so pH at my first half equivalency point, we can substitute. And we know because of our previous examples, my POH is going to be equal to my pKb1, which would give me therefore a pH of 10.3. And then my pH Okay, at my half equivalency for my second equivalency point, I would have this reaction going on. Calculate. And I would get a pH of 6.36. Well, this makes sense because when we look at it, right, this was my initial pH. My pH at my first equivalency is just above 7. My pH at my second equivalency is below 7. My pH at my second half equivalency should be around 7. In this case, it's just below. Okay, so now we have our values. And now we're going to draw, I'm going to add a couple more values in just so that we can see. And now we can join them with a curve of best fit. And we're going to use what we know. We know that it decreases a little bit. And I have my half equivalency. And then as I get close to my equivalency point, I'm going to have a rapid decrease. Then I'm going to decrease slowly until I get to my equivalency. Rapid decrease. And then it's going to level off. So in this case, we have 2 equivalency points, 2 half equivalency points.